Now that we have some basic ideas about exponential functions, let's go ahead and examine their graphs. So I'm going to make a table here. I'll have x values in my first column, and in the other two columns, I'll have 2 to the x, which is an exponential function, and 1/2 to the x. And then we'll go ahead and sketch this on a graph. So let's start out with x is -2, then -1, 0, 1, and 2. I will do a couple evaluations and then fill in the rest quickly. So if I wanted to know what 2 to the -2 is, well, that is the same as 1 over 2 squared, which is 1/4. If you want to know what 2 to the -1 is, you do the exact same thing. You get 1/2. So 1/2, anything to the 0 power is 1, 2 to the 1 is 2, and 2 squared is 4. What about 1/2 to the -2? Well, 1/2 to the -2, there is a property of exponents which says that if you do a fraction to an exponent, you do the numerator to that exponent and divide by the denominator to that exponent. Then, since we have something to a negative exponent, we can move the denominator to the numerator and change the exponent to positive, and we can move the numerator to the denominator and change the exponent to positive. So we get 2 to the +2, that's moving the denominator up, and over 1 to the +2, that's moving the numerator down. And so this is 4. We have 4 here. If you do 1/2 to the -1, then that will be 2 to the 1 divided by 1 to the 1. I did the same steps that I just did, just a little quicker. And that will give me 2. Anything to the 0 power is 1. 1/2 squared. Oh, I jumped ahead of myself a little bit. We need 1/2 to the first power. That will be just 1/2. And 1/2 to the second power. That will be 1/4. While it's a little out of place, I think I'll go ahead and include -3 and +3 also in my table. 2 to the -3, that's going to be 1/8. 2 to the 3 is going to be 8. 1/2 to the -3 is going to be 8. And 1/2 to the third power is going to be 1/8. Feel free to do these calculations on your own if you'd like to, just mimicking what I've done over here on the right. Now that we have our table of values, let's go ahead and graph this and see what the graph looks like. So I have my x-axis, I have my y-axis, and we'll introduce a scaling here. I think I'll start with 2 to the x. So 2 to the 0 was 1, 2 to the first was 2. 2 to the second was 4, and 2 cubed was 8, which I definitely will need some more room. All the way up there. Let's go ahead and label this and this as 1. 2 to the -1 was 1/2, 2 to the -2 was 1/4, and 2 to the -3 was 1/8. We'll go ahead and connect these. With the observation that if you do 2 to a very negative number, something like 2 to the, let's say, -5, that's going to be 1 over 2 to the 5th, which is 1 over 32. When you do 2 to a very negative number, then you get 1 divided by a very large number, which is a number very close to 0. So that's why I have drawn my graph so that it doesn't cross the x-axis, because the y value is never 0, but it does get very close to 0. Now when you do 2 to a very large number, something like 100, you're going to get a number that is extremely large. And that's why I've drawn this arrow over on the right-hand side. Now let's do, or sketch the graph of 1/2 to the x. Let's start at -3. The y value was 8. At -2, the y value was 4. -1, the y value is 2. At 0, the y value is 1. At 1, we have a y value of 1/2, then 1/4, then 1/8. And this connects as follows. So we have our graph of 2 to the x and our graph of 1/2 to the x. By the way, do you notice that 1 is a reflection of the other over the y-axis? The reason why that is as we saw before, 2 to the minus x here is the same as 1/2 to the x. So 1/2 to the x, that's the same as 2 to the minus x. And if you define 2 to the x to be f of x, then f of minus x would be, well, 2 to the minus x. And we know that f of minus x is the reflection of f of x about the y-axis. That's just a small aside of a little application from our previous knowledge. Let's highlight some key characteristics of these graphs. But before I do that, I want to really quickly sketch as well the graph of 3 to the x. So if I do 3 to the first power, I would get 3. If I do 3 to the 0 power, I'd get 1. And if I do 3 to the minus 1 power, I'd get 1/3, which is less than a half. So the graph, just sketching these 3 points, would look something like this. And I just wanted to do this to give you a little bit of intuition about what happens when we change these, what are called bases of the function. If we want to sketch 1/3 to the x, then the graph would look like this. So 1/3 to the minus 1, that's 3. I'm doing this very quickly. You may need to write this on a piece of paper to be able to evaluate this, but doing this rather quickly, 1/3 to the minus 1 would be 3, 1/3 to the 0 would be 1, and 1/3 to the 1 would be 1/3, and 1/3 to the x would look something like this.